The devastating floods in Ireland, causes, impacts, and solutions. Good day. Today, we embark on an in-depth analysis of the escalating flooding phenomena in Ireland. The increasing frequency and severity of floods have profound implications for our infrastructure, economy, and environment. This presentation aims to dissect the multifaceted causes, assess the extensive impacts, and explore viable solutions to address this pressing challenge confronting Ireland. Historical context of flooding in Ireland. Ireland's geographical disposition, characterized by its maritime climate and diverse topography, has historically been susceptible to flooding. Notable historical floods, such as the catastrophic event along the River Shannon in 1925 and the severe Dublin floods of 1954, underscore a long-standing vulnerability. Comparative hydrological studies indicate a significant alteration in flood patterns over the past century, with a marked increase in both frequency and magnitude, deviating from historical norms and necessitating a re-evaluation of flood management strategies. Natural causes of flooding. The intrinsic natural causes of flooding in Ireland are predominantly linked to its exposure to Atlantic frontal systems. The North Atlantic Oscillation influences precipitation variability, while intense extratropical cyclones generate substantial rainfall. The country's riverine systems, such as the Shannon and the Barrow, traverse low-gradient terrains prone to overbank flow during peak discharge. Additionally, the geological composition, comprising impermeable substrates like shale and clay, hinders infiltration, augmenting surface runoff during torrential downpours. Human-induced factors. Anthropogenic modifications have exacerbated flood risks. The accelerated pace of urbanization has led to an increase in impervious surfaces by approximately 12% between 1990 and 2020, impeding natural water absorption and amplifying runoff volumes. Agricultural intensification, including land drainage and removal of hedgerows, has disrupted natural hydrological processes. Deforestation has reduced canopy interception, while soil compaction from heavy machinery diminishes infiltration rates, collectively contributing to heightened flood susceptibility. The role of climate change. Climate change stands as a pivotal factor altering Ireland's flooding dynamics. Recent climatological data indicates an average temperature rise of 0.7 degrees Celsius since the mid-20th century, with projections suggesting further increases. This warming enhances atmospheric moisture capacity, leading to a 6% rise in annual precipitation in parts of the country. Sea level measurements at Dublin Bay reveal an average rise of 2.9 mm per annum over the past 2 decades, intensifying coastal flood risks. These climatic shifts necessitate an integrative approach to flood risk assessment and management. Recent significant flood events. Examining recent events provides insight into the evolving nature of flood hazards. The winter floods of 2009, induced by unprecedented rainfall, resulted in the inundation of over 20,000 hectares of land, particularly impacting the western regions. The 2015-2016 winter season witnessed Storm Desmond and subsequent storms, where peak river flows exceeded previous records by up to 10%, leading to damages estimated at €106 million. The February 2020 floods, associated with storms Sierra and Dennis, prompted over 1,000 insurance claims and highlighted the limitations of current defense structures, emphasizing the need for enhanced resilience. Social and economic impacts. Flooding inflicts substantial economic burdens and social disruptions. The cumulative economic impact over the past decade exceeds €1 billion, encompassing direct damages to properties and infrastructure and indirect losses due to business interruptions. Critical infrastructure, including over 500 kilometers of roadways and numerous bridges, has sustained damage, necessitating costly repairs. Socially, floods have led to the displacement of thousands, with significant long-term psychological effects documented in affected populations. Moreover, the agricultural sector faces losses exceeding €150 million due to crop damage and livestock losses during major flood events. Environmental consequences. The environmental ramifications are equally profound. Flood events contribute to soil erosion, sedimentation, and nutrient loading in aquatic systems, adversely affecting water quality. The influx of pollutants and suspended solids disrupts aquatic habitats, threatening biodiversity. Floodwaters can spread invasive species and pathogens, altering ecosystem dynamics. Additionally, the alteration of wetland hydrology impacts their function as natural flood attenuators, reducing their capacity to buffer against future flood events and necessitating ecological restoration efforts. Government responses and policies. In response, the Irish government, through the Office of Public Works, OPW, has implemented comprehensive flood risk management strategies. The Catchment Flood Risk Assessment and Management (CFRAM) program, launched in 2011, identifies areas of significant risk and outlines strategic measures. Financial allocations toward flood defenses have increased, with €940 million committed under the National Development Plan 2018 to 2027 for flood mitigation projects. Structural measures include the construction of embankments, flood relief channels, and the enhancement of urban drainage systems. Legislative efforts, such as the planning system and flood risk management guidelines, integrate flood risk considerations into spatial planning. Community initiatives and resilience. Community resilience initiatives have emerged as vital components in flood response and preparedness. Local action groups collaborate with authorities to develop flood response plans tailored to community needs. The Irish National Flood Forum serves as a platform for knowledge exchange and advocacy, empowering communities. Non-governmental organizations, such as Friends of the Earth Ireland, engage in education and proactive measures to reduce flood risks through environmental stewardship, highlighting the essential role of societal participation in building adaptive capacity. Flood mitigation strategies. Mitigation strategies encompass a spectrum of approaches. Short-term solutions involve the deployment of demountable flood barriers and improvement of emergency services responsiveness. Long-term strategies prioritize sustainable land management practices. Agroforestry, for instance, enhances soil structure and increases infiltration. Urban planning incorporates sustainable drainage systems, SUDs, using features like green roofs and retention basins to manage runoff. Technological advancements, such as hydrodynamic modeling and remote sensing, enhance predictive capabilities and inform strategic planning. The integration of these strategies is crucial for developing a robust flood risk management framework. The importance of international cooperation. Recognizing the transboundary nature of climate impacts, Ireland actively participates in international cooperation. Engagements with the European Flood Awareness System, EFAS, facilitate shared access to forecasting tools and data. Ireland's adherence to the Sendai Framework for Disaster Risk Reduction underscores its commitment to global best practices. Collaborative research under programs like Horizon Europe enables the exchange of expertise and innovation in flood management technologies, reinforcing the collective effort to address shared challenges. Personal stories and testimonials. Personal narratives illuminate the tangible impacts of floods. Michael O'Leary, a farmer from County Galway, recounts how the 2015 floods submerged his farmland, resulting in a 40% loss in annual income. Through participation in a pilot agroforestry project, he adapted his practices, enhancing land resilience and advocating for community-based solutions. Such testimonies reflect the human dimension of flood impacts and the potential for adaptive strategies to mitigate future risks. Future outlook and predictions. Projections by the Intergovernmental Panel on Climate Change, IPCC, suggest a potential increase in extreme precipitation events by up to 20% by the end of the century under high-emission scenarios. Sea level rise projections estimate an increase of 0.5 to 1 meter, amplifying coastal flood risks. These predictions underscore the urgency for Ireland to enhance adaptive capacity. Strategies such as implementing flexible infrastructure designs and adopting adaptive management approaches are critical. The integration of climate projections into national planning processes will be instrumental in mitigating long-term risks. Call to action. Addressing the complexities of flood risks requires a concerted effort across all sectors of society. We implore policymakers to prioritize investments in sustainable infrastructure and to strengthen climate policies aligned with scientific recommendations. Academics and practitioners are encouraged to advance research in climate resilience and flood mitigation. Citizens can contribute by supporting environmental initiatives and adopting sustainable practices. Together, we can forge a path toward a resilient Ireland, capable of withstanding the challenges posed by a changing climate. Conclusion. In our exploration of Ireland's flooding challenges, we have identified the intricate interplay of natural processes and human activities exacerbated by climate change. The multifaceted impacts necessitate an integrated response, combining scientific insight, technological innovation, and proactive policy measures. As we face an uncertain climatic future, it is incumbent upon us to collectively embrace solutions that not only address immediate risks but also contribute to sustainable development. Let us commit to building a resilient Ireland for the generations to come.